Okay, so before we talk about what we were talking about last time, I want to. Some of you would have gotten an email from me yesterday about this, but we've set up a tool called Slack for the department. It's actually an industry standard. A lot of tech companies now are going to be using this for communication. There's mobile applications for iPhone, Android, as well as apps for both PC and Mac. I think there's one for Linux as well, and then also a website. So if you want, go to cuwcs.slack.com, sign up. You sign in with your cuw.edu account. And once you're in there, you'll see something like here's the Slack application for Mac. In any case, you'll see your computer science channel up here, and we have a whole bunch of channels in here, including one for CSC200. And there's an extra credit opportunity in here just to prove that you've gotten hooked up into the system and stuff like that. So I'll give you a free quiz if you join and get connected. You just have to put your first and last name in here and make sure you've updated your profile to include your first and last name, because you'll have like here in this case, is Fair here yet? You didn't update your profile yet, so you still get your username as Fair5600. But if you update your profile, I'll see your full name there, and that's part of the requirements for getting the extra credit. No, that's fine. I only have my settings turned on so that I see actual student names. So people will still see your ID name by default, but I need to, when somebody asks me a question, I kind of need to know who it is. So that's why you have to fill out your profile, and I'll give you a free quiz. You need free quizzes. You skip quizzes all the time. You miss them. Free quiz.
So you just go to the website and then find CUW Computer Science?
Well, you can do that at Slack, or just go to cuwcs.slack.com. So cuwcs for computer science.slack.com, and this will let you sign up. And then once you're in, you'll see something like this. There's a whole bunch of people already on here. We also have some private groups, so if you're interested in doing Battle Hack Chicago, post something, send me a private message on here so you can send direct messages to people. Let's see, I think I got we'll put Nick on the spot here just as an example. He had a question on the homework assignment. So rather than emailing me and stuff like that, you just put it on here, and I was able to look at the picture that he sent me for his code and give him some comments and that kind of stuff. So this is more of a function of our slow internet than anything else. All right, so in any case, that's a tool that I think will be helpful for us to be using. We also put all the computer science announcements on here. We have the special topics course announced for next semester. All of you will be in CSC200 next semester, which is the course after this one. So you would be able to take the 390 course, special topics, which is going to be iOS programming with Swift for Apple Watch. So we're going to be rating mobile apps specifically for the Apple Watch in that class. So if you're interested, I encourage you to sign up for 390. I also have an announcement up here for senior seminar presentations, which start next week. So if you kind of want to see what's coming up for you here in a couple of years, you might want to come and check those out. That's in this room from 2:35 to 3:50, starting next week on 4/28. Okay, so having said that, I'd encourage all of you to get on here if you want your free quiz, and you can set up push notifications so stuff comes to your phone as if it was a text message or an email. So kind of keeping up with stuff. You can also set up study groups. So for instance, in the 300 class, there's a private group that some students set up for a study group. I'm in the group with them, so they go in here when they're working on their homework, they ask questions, and I can reply to that, or they can collaborate back and forth. So you might want to do that in here as well. If you want to create you can certainly do that in the 200 channel as you're working on your homework if you have questions, or if several of you have groups of 3 or 4 people that work together, you can create your own private group so only you guys see that stuff. Questions about Slack at all? Okay. Alright, so let's go back and pick up where we left off on our code. So for our assignment, we were to write this function called stringToInt that takes a integer represented as a string, so a base 10 integer represented as a string, and it converts it into its integer equivalent. And we had to approach this very similarly to how we dealt with converting binary numbers to decimal as well as octal numbers to decimal and so on and so forth, kind of the same approach. So we're going to need to keep track of our place, and kind of the idea here would be this. So for instance, if we had 25 and we had a string 25 and we wanted to go to the number 25, we have to walk this guy from the end towards the beginning. We'll walk the string from the end towards the beginning. This is the ones place, this is the tens place, this would be the hundreds place, so on and so forth. So it's just how base 10 numbers work. So we want to represent that here in Blockly. So we're going to need a couple of variables. We're going to need place. And we'll start place off at 1. Because we always are going to deal with the ones place when we're on the far right. Then we want to have a loop that's going to start at the end of the string and go towards the beginning of the string. So we'll throw a loop in here. J is going to go from the end of the string, that is the length of our string S in this case, all the way down to 1, counting by -1. So this will take us backwards through our string. Okay, or at least take J on a journey backwards through our string. Alright, so now, as we're walking through the string, we need to grab the current character. And we need to throw it inside of a variable because when we do our math functions, it won't let us do math with something that came out as a string. So we're going to create a variable here. We'll call this guy curchar. And we're going to say curchar is equal to a specific letter from S. And the letter we're interested in is the letter at position I in S. Okay, I'm sorry. Position where are we at? Where's our loop? Why did that change the curchar up there? Did I do that? I did do that. Everybody relax. We'll switch that back to J. It's because of the thing I grabbed. So we're going to set a brand new variable. Where's my brand new variable? Here we go. We'll name this guy curchar before I rename J, because that's the problem. We'll set curchar equal to the current character in S. So there's S, and we're interested in character at position, not that, character position I. Alright, so each time through this loop, except this is J, each time through this loop, J is going to be equal to first the length of S, then the length of S minus 1, length of S minus 2, so on and so forth. Each time through, we're going to set a variable, curchar, equal to the character that lives in S at position J. Alright, so we'll have a character there. Now, what are we going to do with that character? We need to multiply it by our place and add it onto a running total. So that means I'm going to need another variable for holding on to my running total. So I'll call this guy sum. And we'll start sum off at 0, since we have nothing in it at this point. Okay, then each time through, we're going to update sum. And we're going to set sum equal to curchar Well, we're going to set sum equal to whatever sum currently is plus. So that's going to be this guy. So whatever sum is right now plus cur_char times place. There's cur_char, and there's place. All right, each time through the loop, sum will be equal to sum plus cur_char times place. Keep going through the loop, going through the loop, going through the loop. In the end, our answer should be in sum. So we'll go ahead and return sum at the very end. Okay, now one last thing is each time through, place needs to get updated. Right now, place is always a 1. Well, if we're dealing with base 10, it goes from 1 to 10 to 100 to 1,000. So we need to multiply place by 10 every single time through. So we're going to set place equal to the current value of place times 10. So the next time through this loop, place will be 10 times bigger than it was the previous time. That'll handle the ones place, tens place, hundreds place, because we're always multiplying the current character by the current value of place. Make sense? Did you miss that part?
No, I just made it way more complicated. I did like, because I just did each number and then times 10 to the place. So it had a lot.
I see. Okay, now let's just trace this and see how that's working, because for a lot of you, putting this together like this was probably a challenge. Okay, lots of individual steps. None of the steps are very difficult. A comment I make fairly often is something along the lines of all hard problems are made up of a bunch of easy parts. Now, I wouldn't necessarily classify this as a hard problem in the big scheme of things, but maybe for us at this level, it's a little tricky, okay? But it's made up of a bunch of easy pieces. This guy, just setting a variable, looping through some numbers, setting a variable, setting a variable, setting a variable. So we just set 5 variables. And we do a little bit of math each time, okay? But all those, the specifics of each of those is the important part. So let's look at how this works through our code. So what I'm going to do here is I'm going to should have a screenshot that just got taken somewhere. Oh, there it is. All right, so that's our code. And we want to walk through this. So we're going to give ourselves a couple of variables. So first thing is we're going to give ourselves a sample for what S is. Let's say S is going to be 125 for this example. Okay. Similarly, we're going to set place to 1. And it's the number 1, not the string 1. So understand, in Blockly, we basically are working with 2 different types. Things that are strings and things that are numbers. Okay? We also have lists and stuff in that. But for right now, let's just think about it in terms of this. Lists are a little bit more complex animals. Okay, so a sample, somebody might call this function passing in S, and that S might be 125. Okay, it could also be 256. We don't know what they're going to pass in. That's why we have to write this code generically. All right, so it's 125. Place always starts off at 1. And sum will start off at 0. All right, so between these first three lines, that's all we're doing is we're setting up three variables. S has a value, place has a value, sum has a value. S has whatever value was passed into this function, place has a 1, sum has a 0. Okay? Now we're going to start this loop. Now this loop has a variable called j. So let's start off with j here. So now we have another variable here called j. And j's initial value will be the length of s. We see right here the length of s is actually a 3. There's 3 characters in there, right? So length of s is going to be a 3. And j is going to keep going until it's a 1. And it's going to subtract 1 from itself each time. That's what this loop is doing. So j will be 3, then 2, then 1, and then we're done. It'll go to 0, and then the next time up, the loop will fail, and we'll go past the end of the loop. All right, so we're going to start j off at 3, because this is its initial value, which is the length of s. Then we're setting some more variables, char. But before we do that, we need to ask the question, is the current value of j, is 3 greater than or equal to 1? It is. 3 is a bigger number than 1, so we are true for this particular time through the loop. So as long as this is true, we will keep executing the body of the loop. So since j is greater than or equal to 1, we're going to go in here, we're going to set char equal to position j in our text s. So here's s, j is at bucket 3, so that's our 5. Make sense? So we're going to set this guy to a 5. It's actually going to come out of there as a 5 like this, but JavaScript, our language behind the scenes, is actually a loosely typed language. So it's going to be able to deal with this as a number when we do math. The reason we have to put it in a variable, though, is because their math function here won't allow us to pass something that came out of this. It won't allow us to pass turquoise into a blue, is what it comes out to in Blockly. Okay, this guy expects numbers on either side. So when we're multiplying, it expects this to be a number and this to be a number. So we either have to pass it numeric literals, like we got from the math guy here. This is numeric literal. Or we have to pass it a variable that, from Blockly's perspective, might be a numeric literal. If we pass it something from in here, this guy would be a text literal. And that's not allowed in Blockly's math functions. Okay? So this is kind of our hack, playing within the matrix here, that we're going to set chat, this variable, equal to the value that comes out of our string at bucket j, which in this case is a 5, but it's kind of generically stored. So for all intents and purposes, it's stored as the number 5. Make sense? Okay, because we can do math with it. I'll keep it looking like that because that's technically what we put in there, but the math will work. So we have char. Now we're updating sum. So char is currently equal to 5. We're going to set sum equal to whatever it's currently equal to plus. Now we need to do some multiplication. We're going to multiply whatever char is times whatever place is, which is 5. And we're going to add that onto our sum. 0 plus 5 is 5, storing the result back in sum. So sum is now 5. Then we're going to change place. Place equals whatever place used to be, which is a 1, times 10. So now place is now 10. We hit the bottom of this loop, so we spin back up to the top of the loop. We check our Boolean expression again. Current value of j has just got stepped down by -1. So j became a 2. So at the end of our loop, we set j equal to j minus 1. That's essentially what's happening right here. J is equal to j minus 1. So we spin back up. J is now 2. Is 2 greater than or equal to 1? It is. So what do? We set cur_char equal to S at position J. That's S at bucket 2, which in this case is a 2. And this is cur_char, not cur_chat. So there's 2. Then we set sum equal to whatever sum currently equals plus cur_char times place. Cur_char is 2, place is 10, so that's 20. 20 plus 5 is 25, storing the result back in sum. Then we set place to place times 10. Place used to be 10, multiply that by 10, now it's 100. Then we set j equal to j minus 1. The loop does that for us. So now j is 1. Loop back up. Current value of j is 1. Is 1 greater than or equal to 1? It is. It's equal to it. So we'll come in here. We'll get our current char that says give me the character at position 1 in our string, which is a 1. Then we're going to set sum equal to sum plus whatever cur_char is times place. Cur_char is 1, place is 100, 1 times 100 is 100, 100 plus 25 is 125. Then place is multiplied by 10, so now place is 1,000. J gets 1 subtracted from it, now j is 0. Loop back up. Is 0 greater than or equal to 1? It's not, so this loop is over. Okay, j is now an illegal value in our loop, so this is false. So we will not execute the body of this loop again. And what we're going to do is we fall past the loop to the end of our function in this case, and we return the current value in sum. And we see that sum is the numeric equivalent of what S was. See these two numbers match? But this was a string, this is now an int. Make sense? All right, so to solve these problems, you need to make sure that you can do this by hand first. When you draw pictures, understand how you would convert 125 from decimal to decimal. It seems like a stupid activity to do, but it actually proves that it's a consistent algorithm to convert from any base to decimal. Whether you're converting base 4 or base 3 or base 2000. Base 2000 becomes very, very difficult because you're going to have to find a language with at least 2,000 characters in it. With at least 1,990 characters in it. Because when you get to hexadecimal, you have to go through A through F for 10, 11, 12, 13, 14, 15. So the base 2000 would be rough. Probably an alien language would be my guess. One of those guys. So we can do up to base 36 with the English alphabet. What other, there's probably languages with more letters in it than that. Anybody speak another language that has more than 26 letters in it? Anybody, what about Chinese? Yours is more than, are they actually letters?
Oh, just symbols.
Well, I mean, yeah. But I mean, you spell things with those symbols, right? So how many are there?
I'm not sure. I'm going to find out. I know that there's more than 26. It's a lot more than English.
Okay. Yeah, so if we, and that's Arabic. So if we use Arabic, we could represent larger bases.
Start using Arabic.
So start using Arabic for everything. Or we can use the Cyrillic alphabet from Russia uses. Is there more than 26 in that? Doesn't that just look made up? You know, like Arabic looks kind of pretty. And like Chinese looks like art too, is what, right? But doesn't Cyrillic just look made up? Like I've seen like videos in Moscow or something like that, and they're showing like, you know, signs of stuff, and it's like, it looks like just random gobbledygook. I don't know. So let's see, have we offended all the cultures yet? Let me know if I missed any. We'll swing back by. We'll swing back by and get them. Did you get an answer?
28.
20. Oh, we only get 2 more, so we can represent base 38 in Arabic. It's not even worth it. Huh?
More than English.
Yeah, but it's not even worth it.
Easier with the language.
I bet you that. I mean, I think in Chinese. I mean, I think Chinese is basically the source for, like, or at least the inspiration for emojis. I mean, I think there's just a zillion symbols that mean all sorts of different stuff. So I bet you that we could probably do up to base 200 or 300 or something like that in Chinese. I wonder if anybody knows all the symbols, or does, like, sometimes, like, when grandma's writing a letter, she has to go look something up. Like, and how often do they add new symbols in? I don't know. Very fascinating. Don't we? I think we have a Chinese class here, don't we?
Yes.
I should audit that class and learn a little Chinese. Maybe day one they cover the alphabet. All right. So fair, you're going to find out about the Chinese alphabet. How many characters in it?
26.
There's only 26.
Cambodian has 33.
33.
The
Spanish is 27.
Who?
Spanish.
Spanish 27.
Oh,
Okay.
wait. But there's something else with Cambodian that makes it 108.
108. Oh, they probably have, like, little, like, pock marks and stuff like that on it. That's awesome. So we can do.
This is according to answers.com. So
Oh, it's totally accurate. Way. I mean, it's just one step below Wikipedia.
Yeah, because they have 13 punctuation things. They can
That's it. So you said 108?
108.
Okay, so we can represent base 118 with that guy. Solid. All right. Otherwise, we have to go to our alien languages, like I mentioned. Okay. So questions on this? Kind of make sense? You're going to want to practice a lot of these little kind of widgety things like this and take them one little step at a time. When we walked through this, I mean, I know some of you didn't find the assignment too difficult, but trust me, a lot of you did. I got plenty of questions. Okay? As you're walking through this, when you see the solution and you walk through the solution, it probably makes sense. When you have to sit down and write it yourself and you're just starting from the thing, it's like, okay, where do I start? What's the first thing that I do? What's the first picture I throw onto Blockly and hope that that doesn't break it? That's where you need to go back to the drawing board and start with something very simple. So if somebody came into my office and asked me for help on this particular problem, I would have started them off by writing something that just walks through this string backwards. So let me, I'm going to be able to string to int. We'll just write a separate one here. So I would have done something like this. I would have said, okay, let's start with something called print backwards. All right, and print backwards is just going to take a string as a parameter. We're going to test this because I was wondering just a few minutes ago what happens when you have multiple variables with the same name. I think they'll work in context, but we're going to get a little funky down here in our variables. All right, so this guy's going to take an s as a parameter, and all we want to do is print whatever s is backwards. Okay? So in that particular case, we're going to print each character of s. So we're printing multiple characters. How many times are we printing? We're printing s.length number of times, the length of s number of times. So we're going to need a loop. And we can actually use j here if we wanted to. These are throwaway variables, j, I, those things. The danger with using these, we'll go ahead and, well, let's give it, we'll do it anyways. Depending on how Blockly converts stuff, it's possible if you were in a loop somewhere else that was counting on I, and then you called a function that also used I inside the function, are those two going to step on each other's toes? Programmatically, they shouldn't, because the language that it's converting to, like JavaScript, shouldn't have a problem. But if I is 5 right here, and then you call print backwards, and inside print backwards you start it off at 3. You just changed the 5 to 3 in your mind. Realistically, those are two separate i's. One is the I that belongs to the variable scope that this guy was called from. The other one is the I that belongs specifically to print backwards. All right, so kind of something to keep in mind if you ever get some awkwardness. I think the code would always work. I think where it might get confusing is in your own head when you're tracing the stuff. So we're going to go from S, starting at the end, all the way to 1, counting by -1. And we're going to start off at the length of S. And all we're going to do each time through here is we're going to print our string S at position I. And in this case, we're not going to return anything. And let me just make sure we're not, okay, we are still recalling our couple of DoMath stuff, so I'm going to delete these just for right now. So at this point, I have a program that does nothing. We've defined 3 functions and haven't called any of them. Okay, so I'm just going to go ahead and test this print backwards real quick. So we'll call print backwards, and we'll go ahead and pass it the string 256, and we're hoping this gives us a 6, then a 5, then a 2 when we display it. There's our 6, there's our 5, there's our 2. So we are successfully walking this guy backwards. Okay? Now, we're going to add another little step in. So now what we're going to do is we're going to try to do some math with this guy. So this is kind of where we stumble onto the problem of not being able to do math with something that's turquoise. Is that turquoise? I think that's turquoise. It's my interpretation. So I'm going to go ahead, we're going to throw a math thing out here, and I'm going to steal this guy and try to drop it in here, and notice that it's not taking it. Those two colors don't go together. So that's why I needed another variable. Actually, I can do this. We'll just steal kerchar. So that's where I created this new variable, and I set it to our text at bucket I in this case. And then just to prove that I successfully stored something, let's go ahead and just print out kerchar. So this should be the exact same output we had before, except now instead of printing the character directly, we're now storing it in a variable first, then printing out the variable. Okay? Run through that. Same output. All right, well now let's do some math with that guy. So instead of printing out kerchar directly, let's just do a little bit of math. So we'll say kerchar, let's just say times 3. All right, not really doing anything that logically takes us down the path that we want to go, but we know we need to do math with this guy. So we're going to take it and make sure that math works with it. One little baby step at a time as we're kind of organically growing our solution. So we'll do this. So now instead of 6, 5, 2, we should get 18, 15, and 6, which is those values times 3. There's the 18, there's the 15, and there's the 6. Now we know we can do some math. Well, what do we want to do with that math? Kind of get where we're going with this? All right, so little tiny baby steps like that while you're working on your homework. Don't try to solve the problem. Figure out how to solve that. Well, don't try to solve the problem through Blockly at first. Solve the problem as a person first. Make sure you understand the problem that's being asked. Then take only the very first step of your solution and write that in code. Then take the second step, write that in code. Then put those two together and make sure they work together. so on and so forth. Grow it organically. All right, now, going back to the whole reason we had this in the first place, we have our string to int. From last class, we were working on this DoMath guy, and DoMath would take something in this format, a number followed by an operator followed by a number, and it would do that math and produce the result. Okay? And we were building up the left operand. Then we knew we had the plus sign, and we were building up the right operand. But we kind of got stuck here where we had to turn that guy into a number. But now we have that ability. We just wrote it. So here's DoMath. We have three variables, left op, right op, and the position of our operator. So we know where to pick up next time. So the very first thing we do is we find the left op. So this loop potentially is going to start off at the beginning of our string. Well, it definitely starts off at the beginning of our string. Potentially keeps going all the way to the end of our formula, all the way to the end of our string. So in this example here, we're starting right here, and for all we know, we're going to have to go all the way to the end in order to find the left operand, even though we know that we're going to stop right around there, because we're going to eventually hit an operator and say, oh, that's done, we're done. Okay? So we go ahead and we collect that left operand. So we go through step by one. If we're looking at something that's not equal to a plus sign, initially we're only supporting plus signs, right? So if we bump into something that's not equal to a plus sign, then that must mean we're still collecting our left operator, our left operand. So this guy, not a plus sign, collect it. This guy, not a plus sign, collect it. This guy, wait a minute, he's a plus sign, that means we're done collecting our left operand. Okay, so if it's not a plus sign, we're going to append onto left op the text at that position. Otherwise, we're going to set our operator, the guy we just read in, the plus sign, we set his position equal to I. We found an operator at position I. And then break out of this loop. So that'll get us past this loop sitting right here. All right, now we know at this point in time that our variable left op is holding, if it were this example, is holding 25 as a string. We're going to have to convert that later to a number, but we just happen to have the ability to do that now. We just wrote it. Okay, but we're holding it as a string right now. So as of right now, left op is equal to 25. And op pause is equal to 1, 2, 3. It's equal to 3. Now we're going to build up right op. So that's our second loop here. Second loop says we're going to start from op pause plus 1. So that means the step immediately following the position of op. So we're going to start right here and potentially go all the way to the end of our string. In our little example here, that's not far. All right, each time through, we're just going to concatenate on to right op our next value. We don't need to check to see if it's not equal to a plus sign because we already passed our operator. We know that everything from this point all the way to the end of the string is part of our right operator. Make sense? Everything from here on. So even if this was 4200, we know if we're starting right here, all the rest of the stuff is part of our right operand. So we'll build that up inside of right op. All right. Then we were creating a list of left op and right op. But the reality is that we need to just do some math, right? So when we created this list, we were getting whatever's at bucket 1 of our left op, or of our list, whatever's at bucket 2 of our list and trying to add them. The problem is whatever was at bucket 1 and whatever is at bucket 2 were not mathable things. So what it did is it just glued them together. Okay? So we need to turn these guys into math things, numbers. And we happen to have a function that can do that for us. That's called stringToInt. So what we're going to do is we're going to convert left op into an int, and we're going to convert right op into an int. And we'll store those two integers inside of our list. Now, when we bring those out of the list, the plus sign should work. Okay, so all we did is we took our left op and our right op that we found, converted them to integers, and stored them in a list. Now let's go ahead and test this. So we're going to call our DoMath, and we're going to print this guy. And the formula we're going to give this guy, initially we'll just do our test, 25 plus 4. And we hope to get a 29 out of this. There's our 29. Make sense? Go ahead.
With the char, how is the char being converted into the proper integer? Like,
You mean in order for it to work up here? For the math?
no, the string to int function.
Right. So right here, when we take this character and we store it in kerchar, how does it do the math correctly here?
Because aren't those numbers actually higher up, like in the 40s?
Yeah. It's a good question. It has to do with how JavaScript handles it. So what he's asking, it's the right question to ask. What he's asking is this. We're taking kerchar and we're storing in it, for instance, a 5. I don't know why I keep wanting to say kerchat. All right. And then we're getting the current value of place. And let's just say place is currently a 10. Except this is definitely the number 10. Kerchar is actually holding the string 5, or as you put it out, the character 5, although JavaScript doesn't make a distinction between those two. But in either of those cases, the numeric value of this guy might be considered to be his Unicode value. Okay, and what I mean by that, let me just show you here in Eclipse real quick. So this is in Java. So I'll just do a system.out.println. And we're going to say print the integer version of the character 5. And we're going to see that it's not 5. It's a much bigger number. It's 53. Okay? So his question is why isn't it taking 53 and multiplying it by 10? Giving us 530 instead of 50. We are getting a 50 out of this. So we're getting what we want, but why aren't we getting what we think we might be getting? And the reason is that since JavaScript is a loosely typed language, when we get the value out of kerchar, it comes out as just its value, which is 5. And that's treated as a generic value. And if that generic value is part of the set of things we can do math with, then it would work. But now, interestingly enough, if I store 53 in there like that, it gets stored as a string because that's not a single char. So if I try to do that, then it's going to say 1053. It's going to glue it. Well, actually, it'll be, in this case, it'll try to do the math, but I think it'll do the wrong math. It will do the wrong math, I believe. It's actually an interesting question. Let's just do something here real quick. set kerchar equal to 53.
Looks like it does the right math.
Does it? So it really has to do with just the addition. Multiplication, none of those symbols work in the other languages. So it's the, well, those are all math things. Addition has two purposes. It has concatenation as well as addition. So if we do this,
Yeah, the addition doesn't work. It's
it'll concatenate. And then we say print the math of kerchar times 2. This gets us the right math because it looks at the multiplication symbol and says, oh, this can only be math. So give us the number of this and the number of this and go. Which actually is interesting. I'm going to show you something interesting here in a second. So there's our 106. So with that in mind, couldn't we actually have just done this? We could have taken advantage of that fact. And not even written our convert method. Just take advantage of the fact that it will convert this number for us in the event that we're doing multiplication. Otherwise, it treats it as a concatenation. So now we should get whatever. Should get the correct answer. Those are 29. All right. So I guess we didn't completely waste our time, but we didn't actually even use this function in the end. We didn't have to, as long as we recognized that pattern that we could have just multiplied it by 1 to get us the numeric version. Make sense? All right. So homework for Monday. We want to be able to support more complex things. So for instance, 25 plus 4 plus 13. Or 25 plus 4 plus 13 plus 18. So now it can take more than just the left and right. Now it should be able to support as many as we want, but still only doing addition. Make sense? Still, we're only going to do addition. Right now, this will break because we think that everything from this point to the end is all part of our right op. When in actuality, we're going to bump into a plus sign again. Make sense? All right, so I'll give you the XML as a starting point. So for homework, make this guy work. I'll put it back in a working position here, but I'll give you an example of what it should work for. So it should work for as many as we want to put in there. All right, I will see everybody on Monday.
So ours is a lot longer, and simplified will always still get full credit even though it's not like simplified. Okay.
Yeah.
Yeah, I didn't realize. Yeah, I kept trying to put the like, green text.
In fact, in many ways, most of the time, I prefer weird solutions over kind of a more optimized solution because it shows me that you thought your way through it, and that's kind of just your way of doing it. We have a student, Nick. Do you know Nick Largen?
I know.
Okay. Well, Nick Largen, he's one of our. I guess he's a junior. I don't know if he's ever submitted a solution that wasn't weird.
Okay. Yeah.
But they almost always work.
Yeah. I don't know.
He has his approach, and then
I like approaching it a math way, which is sometimes not.
No, I think that's good, and it's going to do you good.
Because I do it totally different. everybody else.
Nope, nothing wrong with that. Well, you say everyone else. I would guess that probably only about 30% of the class got it done correctly.
Oh, okay.
There's a perception of the stronger students that it's easy for everybody.
Yeah.
Yeah, most people in here are struggling with it.
Yeah. Well,
It's kind of normal.
John, my roommate, ended up helping me with like one part because I couldn't. Like,
Yeah.
I got everything but the like getting the text part because I couldn't figure out.
Yeah.
And so I just did equals for each number. If it equals 9, then
Sure. Which is good because that helped you, but it also helped him by teaching you.
yeah.
You know, that's kind of maybe what you guys can start using Slack for, is creating those little study groups and stuff like that.
Yeah.
Oh, You doing lunch, Pebbles?
No, I got an exam, but I missed on Monday.
Oh, so no. So it's not that I don't know. It's no, I'm not doing lunch.
No, I got an exam. I said, I was gonna tell you, I was trying to say that I've been uploading the videos and stuff, but everything is so slow.
Okay.
Like, it literally, I think I just got down to the last video.
Okay. That's fine. As soon as it's done, just text me. That way I can let them know that it's all there.
I used 65% of my Dropbox.
Well, as soon as it's all done, you can just disconnect that share, and it'll all go away. Largen actually ran out of Dropbox space, so I ended up logging into my account on his.
And really uploading all of that.
Oh, I'm still recording. That's fine.